Hello guys, welcome to second session of Solutions chapter Chemistry in CRT Technical Standard. So basically this session we will be talking about solubility. We will be looking two types of solubility. One is solids dissolved in liquids and the second type is gases dissolved in liquids. So let's go and see solubility. So first part, what is solubility? So, solubility of a substance is its maximum amount that can be dissolved in a specific amount of solvent. Okay? So, solubility depends on nature of solute and solvent as well as temperature and pressure. See, the temperature and pressure effects also. Now, you should note that polar solutes dissolve in polar solvents. Say non-polar solutes dissolved in non-polar solvents. So we can generalize this term as like dissolves like. Going ahead, solubility of a solid in a liquid. So here we are talking about solubility of solids in liquid. So solids inside liquid. Now there are two processes that are happening. The first process is dissolution. Dissolution is the process in which a solid solute is added to the solvent and some solute dissolves. When it gets dissolved, it's dissolution process and the concentration increases in solution. So solute plus solvent gives you solution. So this forward reaction is your dissolution. Now sometimes it can also happen that solute particles, okay, the solute particles they combine together and they get separated out. So this process is kind of formation of crystals. So basically from the solution it is going towards the backward direction, the reaction. So it becomes solute plus solvent. So this process is crystallization. So remember that there is always an equilibrium between the two. That is, solution is made up of solute plus solvent, or you can say solvent plus solute gives you solution. Now, one thing that you should focus here on is saturated solution. So saturated solution is the solution in which no more solute can be dissolved at the same temperature and pressure. If you keep constant temperature and pressure, and if you cannot dissolve more amount of solute, then you call the solution as saturated solution. And if you are able to dissolve more amount of solute at the same temperature and pressure, then it is called as unsaturated solution. Next is effect of temperature. So effect of temperature, if in a nearly saturated solution we are talking, in a dissolution process, if the dissolution process is endothermic means requires energy, that is delta H of solution is greater than 0. So the solubility should increase with rise in temperature. Basically it is endothermic process, so it requires energy, and if you increase the temperature or you are giving it energy, the process increases its speed. That means you are increasing the solubility. And if the process is exothermic, that means delta H of solution is greater than 0, actually it should be less than 0. If the delta H of the solution is less than 0, then the solubility decreases with rise in temperature. Okay. Effect of pressure. Now solids in liquids, when we are talking about them, there is no effect of pressure. The reason is because solids and liquids both are highly incompressible, so basically they do not affect it. Next, talking about the second part, that is solubility of gas in liquid. So what is happening here, let's say that this is a closed chamber. I have gas on the top and liquid at the bottom, and let's say that I have applied some pressure by the weight W1. So there is always a state of equilibrium between the two surfaces or two mediums, that is liquid medium here and gaseous medium here. Now, if I increase the pressure by adding two more weights, let's say W2 and W3, what will happen actually? The gas will start to go inside the liquid because the pressure is increasing. So gas is forced to go inside the liquid. So a new equilibrium between the solid liquid and the gaseous phase will be established. Okay. So solubility of gases increases with increase of pressure. So Henry was the first person to give his law about this. So what he said is, at a constant temperature, the solubility of gas in liquid is directly proportional to the pressure of gas. Gas is more soluble if pressure is much more applied. Dalton's law says that mole fraction of the gas in solution is proportional to the partial pressure of gas over the solution. Okay. Again, mole fraction of the gas in solution. We are talking about mole fraction, but in liquid, okay, inside the solution is proportional to the partial pressure of the gas over the solution. That means we are talking about the gaseous phase. So this law, both of them are talking about one in liquid phase and the other in gaseous phase. For example, let's go to the common statement of Henry's law, that is, which is more commonly used, that is this one. The partial pressure of a gas in vapor phase, partial pressure P, is proportional to the mole fraction of the gas X, the solution. So that P is proportional to X. So if you want to remove that proportionality sign and put an equals to sign, the constant Kh. Now this Kh is the Henry's law constant. Henry's law constant is different for different gases, and it is dependent on temperature. So it's like, if you change the temperature, the value of Kh is going to be different. If you change the gas, the value of Kh is going to be different. So Kh is a function of nature of the gas. Now, just to tell you about the values of Kh, you can see here the value of Kh at given pressure. The lower is the solubility of the gas in liquid, okay, for a given value of pressure. So, for example, here the Kh values for both nitrogen and oxygen increase with increase in temperature. Okay, that means to increase the temperature, the solubility decreases. If solubility is decreasing, that means less gas is available. So this is the main reason why all the aquatic animals, they prefer to live in cold waters rather than warm water, because in cold water there is more amount of oxygen and nitrogen present. Since there is more oxygen, they can live easily, whereas in warm water, due to less oxygen, not feel comfortable and they don't want to live there. Now, here is the relation, again the same thing. Like if you see this graph here, that is P is equals to Kh into X. So this is the graph that we are trying to draw of this equation. Is, let's say, Y equals to some M, that is the constant, times X. Okay, you can see this is the graph. Y is equals to mx. It's a straight line passing through 0 comma 0. So this is the partial pressure, and this here is the mole fraction, and the slope of this equation will give you the value of Kh, that is Henry's law constant. Okay, this is graph of Y is equals to mx, or you can say simply E is equals to Kh times X. Next, here you can see that the values of Kh for different gases, for example helium, hydrogen, at the same temperature is different. Same way, nitrogen at little bit different temperature are two different values. Okay, so Kh depends on two things. One of them is the temperature and the other is the nature of gas. Next is some applications of Henry's law. Okay, so first application, increase the solubility of CO2 in soft drink, okay, and soda water. What they do, they actually seal the bottle under high pressure. All the bottles of Coca-Cola, Pepsi or soda, they are all sealed under high pressure. So as soon as you open the cap of the bottle, or you, what happens, the pressure is reduced. That's why the gas is getting released. Next, another application is scuba divers. So scuba divers, what happens when they go inside water, the pressure increases. If the pressure is increasing, the amount of oxygen dissolved in their blood will increase. Pressure is increasing. Now that is fine. There is no problem in that. They have more oxygen in their blood. The problem comes when the diver come up towards the surface. Because pressure is gradually decreasing. So this decreased pressure releases the dissolved gas, leads to the formation of bubbles of nitrogen in the blood. Okay, because they have nitrogen as well as oxygen. So that gas which is dissolved comes out. So this gas which is coming out blocks the capillary and creates a medical condition called as vents, so which are painful and dangerous to life. There are a lot of restrictions for scuba diving. Okay, scuba diving is done for some construction work underwater. They go up to 50 meters of depth, so there are special chambers which are used for them. Okay, and yeah, it's like there is age restrictions also, like you have to be quite physically fit, and then you should not be over 50 years of age. Like you have to pass an examination before going underwater. Now similarly, there is another application, like at high altitude the partial pressure of oxygen is less. For example, like if you are going to climb Everest, okay, so for climbing Everest there is always something called as base camp. Base camp is like you have to go there and you have to stay there. The idea is to adjust to the environment because the oxygen there is quite less. If you have low oxygen in your blood, so low blood oxygen, it causes the climbers become weak and unable to think clearly. So because of this, they they need to adjust to the environment. Now this condition of having low blood oxygen is called as anoxia. Now effect of temperature. Okay, effect of temperature, already said that solubility of gases in liquids decreases with rise in temperature. The idea is if you increase the temperature, the gas will vibrate, or let's say attain some vibration and escape in the atmosphere. That's why cold drink are said cold drink. Okay, you, if you warm cold drink, what will happen? All the gas which is there, it will evaporate, and that's the main reason why you keep the fridge. And also the thermodynamically you can say that dissolution process is an exothermic process. So solubility should decrease with increase in temperature. Solubility will decrease. This is the effect of temperature, and that's all. Okay, I hope you guys enjoyed the session. See you all in the next session, guys.